machine learning with online managed endpoints. Told you could have been a longer title, but not by far. All right. This is what we're going to talk today. But first, let's talk a bit about what these online managed endpoints really mean. Yeah. What are they? Well, to quote Microsoft Learn, an endpoint is an HTTPS endpoint that clients can call to receive the inferencing or scoring output of a trained model. Yeah, so basically it's an URL. Yeah, there's you can see that it is a REST API. Clients call it, it answers back. That's what an endpoint is. It answers back with the predictions from your models. That's really important. We'll circle back to that in a moment. All right, but what are online endpoints? Because you see in Azure ML, there's two types of endpoints, the second version of the SDK, of course, batch endpoints and online endpoints. Yeah, online ones, they're for real-time machine learning. Yeah, in case when customers just want an answer, they want some predictions, they ask your model for those predictions, it answers back, they're good to go. Yeah, as opposed to batch where things are different a bit. I allocated some time in the second part of this presentation to get into more detail for batch machine learning and real-time machine learning. But for now, keep in mind that batch is not real-time and real-time is real-time. Yeah, we're going to talk about online, which is real-time. And let's see what options do we have in Azure, right? Imagine you have a fancy new model. You've trained it, you or your data scientists worked for weeks, even days, to train it and to get the best accuracy. Then what do you do with it? Because all alone on your data scientist's machine, it's not terribly helpful unless you take their laptop, turn it into a server and just be done with it, right? But otherwise, it's not helpful. You need to put it somewhere. And in Azure, you get the chance to put it in a really good place. Let's see. So this screen is a metaphor. Yeah, you see it's split in two because in Azure ML, there's two SDKs. There's the old one, the SDK v1, and the SDK v2, which is new. It got released this year. It's shiny, it's bright. The fact that one half of the screen is barren, much like some fields you've probably heard about. Yes, that's the metaphor, because you see the SDK v1 will get, it is a bit on the deprecated side. It will not be supported in around 3 years' time. Yeah, so with September 30, 2025. And yeah, up until then, you will be able to install and use it. After that, you'd better think of a migration plan relatively fast. Yeah. So what are we going to talk about today? We're going to talk about the second version of the SDK. You see, in the first version, you could have deployed the service with Azure Container Instances, or if you like, paying with Kubernetes. In the second version of the SDK, it's managed endpoints and also Kubernetes, because why drop a good thing, right? We're going to talk about managed endpoints because they're a bit easier. Yeah, and let's talk a bit about what workflow would you have for deploying your models, right? Again, the scenario is you have trained the machine learning model, you want to put it somewhere, so that the rest of your application can use it, right? And this is what Azure ML excels in. Yeah, it makes it really easy for you to operationalize your machine learning models. And I've included here a chart from MS Learn, yeah, highlighting a pretty basic architecture, but one that I think it underlines the major components of online endpoints in this regard. Yeah. So as I mentioned before, an endpoint is just, it's a REST, it's an URL. Yeah, it's a REST API. Well, API is a bit much. It's more, it's just an URL. You can't really change it. But an endpoint, which is called by your customers, or by your applications. An endpoint can have one or more deployments. Yeah, and each deployment can contain its own code and its own models. So this makes it, this is really cool. This means you can have several models running in the same time, and you can ask your load balancer nicely. And this is all baked in. It's really easy. I'll show you how to do it in a moment. But you can ask your load balancer to, I don't know, send 90% of your traffic to your stable, your main model, but then run micro experiments with several other models, and 1% traffic to this one, 1% traffic to that one, 1% to the other one. Really nice. And you get this, you can implement this really easily. Yeah. Yeah, where do I sign up? I don't know. So what's the workflow? What do we need in order to make this run? Well, a script. Yeah, you need a script. The script would be the interface between your model, your trained model, and the client's calling the API. Yeah, so basically a script that's responsible for translating the, I don't know, maybe you're using JSON, the JSON inputs, the JSON payloads that your service receives to what your model can actually handle. Yeah, to a matrix, to an array of vectors. I don't know, whatever your model supports, it's flexible. Yeah, so you need a script. You also need an endpoint, obviously, that's the URL. And you need one or more deployments. I'm going to show you how to do just one, but the others are basically the same. And then you're in the money. You're free to deploy your model and see how many requests per second it can handle. So let's see a bit how to do this. Yeah, I hope you're seeing. I made this as large as I could. I do hope it's visible on for everyone. I'm going to talk you to the script, but no worries. It's really basic. Basically, this inference script that we have has two standard methods. Yeah, you need to put them for each and every service: an init and the run. Yeah, and init, this method runs when the container is initialized. Yeah, when it started. It's responsible for. Well, it's responsible for whatever we want it to be responsible, but its purpose is for you to be able to cache stuff, to load your models. Yeah, you don't want to load your models off the disk every time a request comes. Yeah, your requests need to be lightning fast. Yeah, you need to be able to return answers to your customers as fast as possible. Yeah, whereas in init, you can take your time. Just a little bit. So this is the place where you're loading your models, where you're doing caching precalculations. I don't know, whatever you need to do. It runs once when the container is started, and then that's it. Yeah, it doesn't run. So in this case, I'm using it to load the model. And then in the run method, all I do, I'm trying to get to have this as slim as possible. Yeah. So all I'm doing is processing the parameters, yeah, parsing it as JSON, extracting an element, and then running predict on it. Afterwards, I return the results as fast as possible. Yeah, I don't want to wait here because every extra operation increases latency for our customers, and we don't really want it. But that's the inference script. That's all you need to do. This is the glue between your model and the people or services calling your API. Yeah, that's the first step. All right. Second step, we need to create an endpoint. And one thing I love in the SDK v2 is that they've reimagined the command line experience. Yeah, you could do this in the Python SDK, but I'm starting to prefer creating and managing resources in the machine learning CLI. Yeah, it's an extension on the Azure CLI. I'll show you in just a moment, but basically, well, it looks just like this. Yeah, so if I want to create an endpoint, all I need to do is AZML, and you know the AZ command, yeah, is the standard Azure CLI. Use it to interact with everything Azure. Yeah, but it has the ML extension, And I'm using the online endpoint command, yeah, to online and create command for online endpoint. And I'm creating an endpoint based on this YAML file. Yeah, and what's in this YAML file? Almost nothing. Yeah, it's a schema. It has a name. Yeah, an endpoint needs a name, must have. This name will be part of the URL of the endpoint, and it's also used from deployments when you reference it. Yeah, so it needs a name and an authentication. Yeah, in our case, I'm using bearer authentication. We'll discuss the other options in a moment. Yeah, but using bearer authentication, this is by default. Creating the endpoint, if I were to run this command, it would take something like 30 seconds to a minute, as opposed to the deployment creating command, which is not fast, let's say. But right, this is how you create an endpoint. If we were to create an endpoint with 0 deployments, you would be able to call it, but you would get a really friendly message saying that this endpoint has no deployments, please deploy something here. Yeah. All right, so let's deploy something there. This is how you structure a deployment. Yeah, it's also a YAML file. It's a bit more complicated, but not by much. You see, we define a schema. It has a name. Of course, it has a name. I chose blue because I'm really original. It references the endpoint by name. It references a model. Yeah, very important. You need a trained model to be able to deploy this. So it assumes you have a model somewhere nearby. In my case, in up 2 levels, and then in model. And it will get that model and it will include it in the deployment. Yeah, so you can access it from your scripts. Next, what does it do? It asks for a code configuration. Yeah, a directory containing the code and the script to use when scoring, because it will create a web service that based on that script it will run that. It will run it. It will run its methods. All right. Apart from that, it also needs an environment. Yeah, a Conda environment. This is used. It's really cool. It's used to specify which version of Python you want, which packages you need. Maybe you need scikit-learn. Maybe you're doing something with deep learning. Yeah, I don't know. You're free to do whatever you want, basically, yeah, and specify the packages you want. So you also can get that here, and Azure ML will handle the creation of the Conda environment. It will install the packages. You get all of this really easy. Also, an image, yeah, a Docker image. Azure ML has several standard, let's say, Docker image. You're free to use one or come with your own. An instance type, yeah, the size of the machine running the service, and an instance count, yeah, how many nodes. Now, what you should keep in mind is that a service, yeah, a real-time endpoint, runs this machine 24/7 for a month. Yeah, so that means you're built for the whole month. But that's just if you have one instance. If you have more instances, yeah, this scales up with the number of instances. So if you don't need it, maybe don't set 10 instances just to see if it works. Yeah. All right, that's how you structure the deployment. That's how you create the deployment really easy. AZML online deployment create. The other command was online endpoint create. That's all you need. Specify this file and it works. And if you were to try running a curl, by the way, this is how the endpoint looks like. This is the URL you get. You'll see it includes the endpoint name and the square ending. Yeah, you will see that it has no valid deployment. Why? Because I deployed something, but I didn't activate it. So I need to activate it. Yeah, how do I do that? I talk to the nice load balancer in there, and I tell it, look, I want you to redirect 100% of my traffic to the blue deployment. Yeah, if I had more deployments, I could have played with them. Importantly, is the numbers add up to 100. Yeah, but otherwise, you're free to redirect your traffic however you want. Pretty cool. Yeah, so if I were to run this command and update the traffic and update the endpoint to redirect all the traffic to the blue instance, it works. Yeah, By the way, this is a tiny command. Yeah, what I'm doing here, I'm using better authentication with curl. I'm telling it this is a JSON file. I'm sending it this JSON file. It's light. It has numbers. Who knew? And it returns more numbers, but those numbers will make us happy. Yeah? And really happy if they're the right numbers. Yeah, so this is how you use. This is how you deploy something in Azure ML with online endpoints. It's, I don't know, when I saw this workflow and tried it out, I quite enjoy this. It's fantastic how easy it is. All right. And I also wanted to tell you a bit about 3 of my favorite features in here, because you just saw a nice demo workflow, but okay, let's talk production. Yeah. I'll tell you the 3 favorite features for managed online endpoints in production scenarios. Yeah. Well, better tokens. I'm channeling my inner dad. I like the fact that it has built-in security. The old ACI Azure Container Instances experience was that you deploy them, they would have 0 security. Anyone could call your endpoint, and if you wanted to have some security added, you would need to jump through some hoops. And here I get this for free, and I can use bearer tokens, which you get from your Azure portal. But also I can use Azure machine learning tokens, which have expiry dates, refresh time. If you need more advanced security, you get this for free. I love them. Native blue-green deployment. Yeah, again, man, I love being able to run multiple versions of my models or different models even at the same time. Yeah, imagine you create a tabular, I don't know, classic machine learning model. You do something with gradient boosted trees because you love them. They're the best. You should always use them, right? But you use something like that, and then you have somebody come and say, "Look, I want to use PyTorch." And you say, "No, you don't want to use PyTorch. It's heavy." But they insist. So then you give them a small deployment. Let's say they manage to build a model and it runs sufficiently fast. Yeah, you deploy that, redirect it to 1% of the population, and demonstrate to them that it's inferior to XJBoost, because that's how good gradient boosted trees are. Yeah, and you're not limited to just 2 deployments. You can have as many as you like. In my case, I couldn't help trying out stable diffusion with that prompt. You know, a salmon swimming down a river, and you get that those pictures shared on the internet where there's sushi everywhere. I tried that with stable diffusion. It doesn't work now anymore. But if you make it a delicious salmon swimming down the river, you get this. I'm really proud of myself. All right. Third feature, you get auto scaling, and it's really easy. So let's say you don't, as I mentioned before, you don't really want to assign as many instances as you can to a deployment. Yeah, it's best to be conservative so you don't pay through the roof. But then when you get lucky and you're successful and everybody hears about your service, what do? Well, with Azure Monitor and its integration with managed online endpoints, you can set rules such as, I don't know, when CPU usage on average is higher than 70% over 5 minutes, then increase the number of instances, yeah, or decrease it, or it's lovely. I absolutely love it. It's one less thing to worry about, yeah, if you get lucky and you have success. Yeah, so basically these were the 3 things I wanted to tell you. And now I wanted to talk a bit, hopefully we have some more time, about something more esoteric. So what's real-time machine learning versus batch machine learning? Because I promised I'd get to this at the beginning, but then I wanted to make sure I understood, I explained the Azure ML experience. But let's talk a bit why you would choose to use real-time inference versus batch inference. right? And what is real-time inference versus batch inference? Well, let me give you an example. If you have a job, let's say, and you can get away with it not being you can get away basically with your forecasts not being invoked using a web service, let's say, and maybe or they don't need to be real time, they don't need to react to the features that you're sending. It's best to, or for me at least, I think it's best to use batch machine learning. Maybe you can have a job, you can schedule a job that pre-calculates and generates forecasts, persists them, I don't know, in Redis, on disk, on a storage somewhere, and then when the time comes, they just read from disk and return those forecasts, if you're able to. And you can have the job running, I don't know, daily or every hour if it's fast enough. And you get less costs. So for example, let's say you want to, I don't know, forecast the energy prices for the next period. Maybe the conditions for the next year, maybe the conditions don't change as often to warrant using real-time machine learning. Maybe they change every week or every day, or with the current geopolitical climate, maybe more often than that. But this may be a good scenario for batch inference, for running a job regularly, persisting the results, and then just reading them and using them. Whereas in real-time inference, that's when you have a web service. That's when your customers talk to your web service. Well, and by customers, I wanted to say clients, and by clients, I want to say maybe web applications or Java, .NET services, whatever. So not necessarily people. Yeah, but you have those clients asking, look, in these conditions, for these features, what's the forecasts? What's the prediction? And you have the services answering them. So that's what I'd use real-time inference. Now, I've also prepared a small, let's say, example/discussion with voting. I'm not sure if we have enough time, or guys, should we take some questions, or should we?
We still have 5 more minutes.
You have 5 more minutes,
so
please proceed. There are no questions.
All right. Brilliant. Well, let's discuss 3 scenarios for either real-time or batch machine learning. And to be honest, I borrowed them from an excellent Airbnb article. It's about how they built their search ranking for machine learning. And I dropped a headphone. It's fine. But yeah, it's how they build their search ranking for their Airbnb experiences, right? And you can see the URL below. It's really cool. I urge you to read this. All right. And I also prepared a small voting experience. Now, I think there's a bit of time. So I ask you to go to menti.com and enter this code. It's 3678. Who do we appreciate? 3678-6185. And I'm going to follow up with a few questions. Basically, it's the same question, but applied to 3 different scenarios. And yeah, basically, what's going to happen is I'm going to describe a scenario that they took into account, and you're going to vote whether you would use batch machine learning or real-time machine learning. And we'll discuss a bit the results. Yeah, so go to menti.com, use the code 3678. Let's see if somebody already voted. No, thank you. All right. How do they start? Well, at the beginning, to create this recommendation system for experiences. Well, but first, let me describe that system. Maybe that's the best. What did they want to do? They wanted for each person who visited their site and wanted to look for experiences, or Airbnb experiences, they wanted to display the ones that were most likely to be chosen by that person. Yeah, and they did this gradually. First, they took into account some experience features, some features related to the experience when building this recommendation system. And stuff like experience duration, whether it was 1 hour, 2 hours, 3 hours, whatever, its price, its category, the number of reviews, what those reviews said, yeah, how many bookings it had in the past, stuff like that, right? Now, if you were, let's say, a data scientist at Airbnb and you had these features available to build a ranking system for experiences, you had these experience features, how would you do it? Would you do it in batch or in real time? Yeah, and by batch I mean, would you I don't know, create a job that runs periodically and generates the best experiences to display to customers, or would you create a web service that customers can invoke and it returns the top 5, I don't know, top K experiences for that customer? Yeah. We have 1 vote for real time, 3 votes for batch. So it's like 75% batch, 1% real time. Well, that's how they did it, actually. They used batch inference for this. What they used batch inference? Because it was easier, right? Machine learning, MLOps is getting there. It's easier and easier, but it's not always easy. And batch ML is quite a bit easier, right? So in this case, it was simpler for them to run a job, run it daily, or whenever new experiences were added, generate probability index for that experience, and then dump them all into Redis. And when somebody would be searching for an experience, they would just get the results from Redis. It would be lightning fast. That's the way of Redis. And it wouldn't complicate things very much. Yeah, so that's actually how they did it. I think if I talk for a bit more, then real time would win. Let me reset the results. All right. Okay, next one, and I think that's the final one. Well, but rather than rush through this, I don't know. What do you guys say? Should I rush through this? I think not.
We should. Oh, sorry, I was still muted.
Sorry.
You can hear me right now, Vlad, right?
Yes.
Okay, perfect. We're actually at the end of time, so
yeah.
we should start going to the other session. But I think it was already an awesome comparison that you did between the 2 services. Well, the same service, but the 2 different ways of deployment. And indeed, the new SDK v2 with the YAML files makes things quite a bit easier. But again, it was, for me personally, it was a big change again from v1 to v2. You had to get used to it again.
Yeah. Okay. I need to rewrite all my pipelines now.
Yeah, exactly.
But I have 3 years.
Well, yeah, that's indeed true, and it's good for business, huh?
Yes, wink.
All right, Vlad, well, thank you very much
for having me, Dan.
Thank you for your time. Enjoy the rest of your day, and talk to you later. Bye-bye.
You too. Congrats for creating this wonderful conference.
Thank you so much. Bye-bye.
Thanks. And that's